Sharing of attestations. See, the sharing of attestations right now is a problem. It's extremely inefficient. We have all sorts of explicit and implicit attestations we share as part of going through life and doing business and governance and so forth. And we find that we share a lot of those attestations over and over again. Do I have to tell you that again? As an individual, it's annoying. As an organization, as a large corporation, it can be very, very expensive. Our methods of sharing tend to be ad hoc. We set up different methods for different purposes over and over again, it making it very inefficient. And then when we try to have access to and actually use those attestation, we really can't get to them in time to actually do things with them in an efficient manner, either for cost or for response for security incidents. And supply chain attestation sharing is critical for the security of supply chains and critical infrastructures, and for the efficiency and economic needs of the supply chain participants. So bills of material for software and hardware are in critical business and civil infrastructure are paramount. We need to know what's inside our grids. We need to know what's inside our business systems. We need to know what's inside our data centers, because that matters. We need to know the vulnerability research, the indicators of compromise, the custody, the provenance, the origin, country of origin, place of origin, who touched it before we got to it. And we need to have that information at hand and available for practical use, such as responding to security incidents and other daily normal processes. So when you think about supply chain security, there are three questions to ask and to answer. What are you writing down? Where are you writing it down? Who gets to read it? The first is taxonomies. How do I read this? What is a bill of materials? What is a software bill of materials? What does an attestation about provenance look like? What's an indicator of compromise look like? Policies are who gets to read that. What we're trying to solve with attestation channels is where do you write them down? How do I put together a digital bill of materials out of attestations that I can get in a timely fashion and know their provenance? So a DBOM itself is that stack of attestations. So you take any given individual asset, whether it be a physical device like a phone or a computer device, a piece of software, a person, a piece of hamburger, whatever it is, it's been attested to through its life cycle in various ways. When you can access all of those quickly and efficiently, you have a digital bill of materials. So to create a digital bill of materials, you need two things. You need attestation nodes, DBOM nodes, that allow you to involve yourself with channels, to create channels or to subscribe to other channels that have been created for your purposes. So a DBOM channel is just a repository and a policy. So the repository type is chosen by whoever creates that channel. We'll talk about that in a moment. It could be blockchain, could be flat databases, doesn't really matter for our purposes. And the policies tend to be an implementation of the existing relationship, the contracts, the regulations, the processes, what defines the relationship among the parties who are sharing the attestations. Channel types can be private. They can be just myself as an organization. I'm going to create a channel where I'll attest to processes that I keep internally. They could be private amongst a set of parties who want to set up the rules for what it is they're sharing about. Broadcast channels can be very common as well, where, for example, as a vendor with multiple partners, all of the same class, you may want to broadcast information to them as a group. And a public channel is exactly what it sounds like. I, as an organization, for example, may have information that I want everyone in the world to have, that I don't want to repeat, that I want to put out in public as myself very clearly and for all time. And I would then perhaps create a public channel and allow everyone in the world to have access to it. An example of a private channel, in this case a private channel with read-write by all using distributed ledger technology, having content of the private attestations regarding the software created by the vendor and used by the integrator in the enterprise and audited by the auditor in this case. And they each perform the normal business functions as they would previously, except now those functions are tied to and related to an attestation channel that each can use to verify that the work has been done and to act on the work in future. So the simple example in a supply chain model, if we follow this through, we're taking individual channels. There may be multiple channels between these organizations, but to keep it simple, we have an OEM who is buying parts from two different manufacturers. In this example, the OEM has created two channels. You'll see the color match, a upstream private channel that it is requiring by contract manufacturer A to attest to various things on the channel. The hardware, software, bill of materials, whatever attestations are defined by that contract relationship. In this example, manufacturer B already has a public channel where information for our purposes is available. So OEM A, even though they have a similar relationship with manufacturer B, they don't ask for that information again. They source that information on the public channel where it's already been attested to. OEM A then takes these products from different manufacturers, puts them into a product, sells it to integrator in blue at the below, and creates a channel for that integrator to access the attestations created by the OEM. The integrator then takes that product from OEM A, takes another product from OEM B. OEM B, in the contract between the integrator and OEM B, is required to attest on the channel created by the integrator private channel in the lower left-hand side. Integrator creates a solution out of that, delivers it for enterprise A, and attests on the channel created for that purpose for that enterprise. So everybody can have access to the information they need. The contract relationships define the policies that allow chaining the access to information from end to end. So the DBOM node itself looks like this. On github.com/DBOM project, you can download the open source version of this. The DBOM node code itself is the gateway that enforces policies on the repositories in specified channels that an entity is allowed to have access to. As discussed, you see on the right-hand side, permissioned distributed ledger blockchain repositories, public distributed ledger repositories, traditional database repositories. For the DBOM node doesn't care what type of repository you're using. Repositories have characteristics that lend themselves to different types of attestation sharing, but the DBOM node is independent from that. On the left-hand side, you see all of the enterprise services that different enterprises do with attestations. As an example of DBOM in use, at Unisys, we create mainframes and have been doing for many, many years that run critical business applications. We use DBOM internally to look inside those mainframes and be able to say, for example, in this screen capture, that the firmware on an individual chip is running at an individual at a particular firmware level. That helps us reduce our cycle time, get better customer satisfaction, spend less time tracking down parts, and keep things running better, basically. So, in effect, we're moving into the time of attestations, where standardizing attestation sharing will be reducing costs, improving agility of different actors in different markets, providing competitive advantages for those actors. DBOM nodes are what allow enterprises to use the attestation channels that provide these benefits. And DBOM channels are what provide that timely and actionable access to the attestations. So, again, on the screen is the DBOM GitHub project. There'll be a SaaS version of DBOM available in 2021 from Unisys. And if